Welcome Greyfire pupils to the final part of the straight line notes, and the last part is intersection of lines, a very popular past paper type question where in parts A and B you'll be asked to find equations of lines, often perpendicular bisectors, altitudes and medians, and then part C you're asked to find where the particular lines meet. So we're trying to find those coordinates. Okay, and the method that you use for part C is essentially simultaneous equations, so something familiar from National 5. So we'll work through parts A and B as a wee bit of a recap from the median and the altitude in the previous parts of the notes, and then work out our coordinates in part C. So again, what I'm going to do is going to start with a quick wee sketch. So triangle PQR exists. Create a wee bit of space up at the top here. So we have point P is 1, 7. Q is 11 minus 3. And R is 2 minus 6. So hopefully the rough sketch will give us a wee helping hand. So we have P, it's 1, 7. Q is 11 minus 3. And R is 2 minus 6. So in our first part, in part A, find the equation of the median from R. So again, thinking back the definition of our median. So a median from R goes from R to the opposite side of our triangles to meet PQ right in the middle. So in part A, again, the fact that it's an equation of a line, y minus b equals m x minus a. And to use that equation, I need a point, I need a gradient. So thinking point, gradient, equation. For median, our point is a median from R. We've got the point R, just 2 minus 6, but we will need the midpoint of PQ to be able to work out our gradient. So midpoint of PQ are adding up our x over 2, add up our y over 2. Okay, so just to give us a wee bit more space within the question, if I'm looking for the points PQ, I'm just going to copy these out. And that allows me to label accordingly. X and Y my first, X and Y my second. One plus 11 over 2, and 7 plus minus 3 over 2. 12 over 2, 4 over 2, gives me the point 6, 2. So in this case, my midpoint M is 6, 2. I'll mark that on to keep myself right. And my gradient of R M. And once again, just to lessen the chance of mistakes being made, R is the 0.2 minus 6. M I've just found to be 6, 2. X and Y of my first. And X and Y of my second. Two minus 6. 6 minus 2. 8 over 4 is 2. So to be able to work out my median, I need a point. I've got the choice between R and M. I will choose M just simply for the fact that it's both positive values, and M is a gradient of 2. AB, Y minus 2 is 2, X minus 6, Y minus 2 is 2X minus 12, and adding 2 to both sides is 2X minus 10. In part B, let's go back up to our diagram. Calculate the equation of the altitude from P. So thinking back to the definition of an altitude, the altitude from P will go directly down and meet the opposite side, in this case RQ, at right angles. So again, thinking it's an equation of a straight line, so y minus b equal to m x minus a, where I need a point and I need a gradient. In this particular instance, point gradient equation, my point from P, from my altitude from P, meets somewhere on RQ. So I have the point P, and that will be the coordinate point that I will use within my equation. So P is the 0.17. To find my gradient, I need my gradient of the line RQ, and then work out my perpendicular gradient to find my altitude. So M R Q. Y2 minus Y1 over X2 minus X1. R is 2 minus 6. Q, 11 minus 3. Label my points. X and Y my first. And X and Y my second. Y2 minus 3 minus 6. And 11 minus 2 minus 3 plus 6 would give me a positive 3 all over 9, which is equal to 1/3. So that's my gradient of RQ. where my perpendicular gradient, so for m for q times by m perpendicular, that must equal to -1. So m perpendicular would be 3/1 negative, which equals to -3. So within my equation, I need a point, which is P17. I need a gradient, which is -3. AB y -7 is -3 x -1. Y -7 -3 x plus 3, and if I add 7 to both sides, y is equal to -3x plus 10. Okay, in part C, find the coordinates of the point of intersection of the median and the altitude. What I need to do is to take both my equations, y equals 2x minus 10, I'll use my space down at the bottom, and my second equation from part B, y equals -3x plus 10. And I look to try and find the point of intersection. And I'll solve this in two different ways to show you your options. First of all, simultaneously, and we're looking to eliminate our either x or y. So rearranging the equations, my first equation can be rearranged to be 2x minus y is equal to a positive 10. Subtract y to both sides and add 10 to both sides. And my second equation, 3x plus y is equal to 10. So equation 1 and equation 2. I've got my elimination lined up. So if I take my first equation and add it to my second equation, I will eliminate my y. 5x is equal to 20. 2x and 3x is 5x, 10 and 10 is 20. So dividing both sides by 5, x is equal to 4. And once I have my x value, I'll sub x equals 4 into my choice of 1 or 2. Equation 2 has positive values. So 3 lots of 4 plus y is equal to 10. 12 plus y is equal to 10. And I take away 12 from both sides. Y must equal to minus 2. Therefore, my point of intersection, answer the question, is the point 4 minus 2. Alternatively, In this particular case, I will be able to solve simultaneously by substitution. Y is equal to y. In that case, 2x minus 10 is equal to minus 3x plus 10. I create myself an equation. If I add 3x to both sides, five x minus 10 is equal to 10. 5x must equal to 20, add 10 to both sides, divide by 5, x is equal to 4. And same situation as my first method, sub x equals 4 into my second equation, 3 lots of 4 plus y is equal to 10. 12 plus y is equal to 10. And if I take away 12 from both sides, y is equal to minus 2. And again, I would answer my question, and therefore point of intersection is x is 4 and y is minus 2. Either approach is absolutely fine, it's just whatever you are comfortable with. Approach number 1 is potentially more familiar to you, going by your simultaneous equations that you'll have solved quite regularly within National 5. And as always, PowerPoint will give you an idea of some similar type questions.